Welcome to today's webinar. Today we show you how to calculate concrete foundations with geotechnical design checks in Rfem 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the technical content of the website, German and English webinars, the customer projects, newsletters, and so on. I will be the moderator today, and I will answer your questions during the webinar. My colleague Ann-Kathrin Danwert will do the presentation, and she will introduce herself. Okay, then I say something how you can ask questions. At first, I switch off my webcam that you can see the full screen. Just press the button with the question mark, then enter your question in that field, press send, and then I will receive your question and I will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's for the moment all from my side. I hand over to Ann-Kathrin. Ann-Kathrin, you can start.
Thank you, Andreas, for the kind introduction. My name is Ann-Kathrin Danwert, and I work as a product and solution engineer at Dlubal Software. Today, I will present the webinar on concrete foundations. First, I will give you an overview over today's webinar. We will start with the different types of foundations, which includes foundation slabs, block foundations, bucket foundations, and stepped foundations. Next, we will discuss the additional foundation loads, such as surface, line, and concentrated loads, as well as earth covering and groundwater. In the third section, we will look at the automatic or manual creation of corresponding characteristic load combinations, as well as the necessary design situations in the ultimate limit state and serviceability limit state. Following that, I will provide an overview of reinforcement input. Here we can define mesh reinforcement, rebars, or a combination of both for the representative type of foundation. Then we will review the geotechnical proofs. This includes equilibrium of structures, ground failure, sliding safety, foundation rotation, and large eccentricities. Finally, we will cover the printout protocol. I will show you the foundation properties, the relevant verifications, and the representation of reinforcement, and how you can put these into the printout protocol. Let's now switch to Rfem 6. I already created a steel hall with concrete columns and concrete foundations for you. First, I will show you the basic settings where the foundation add-on needs to be activated. You can find it here at the top. Under the add-ons, you need to make sure that the concrete foundations are activated. Concrete design doesn't necessarily need to be activated, but since I have a model with concrete columns here, I activated this for this webinar. However, for the design of concrete foundations, you do not need this. Once the concrete foundation add-on is activated, we get new folders in the navigator, which I will now show you. Here we get the types of concrete design. Normally we won't get effective length, reinforcement directions, surface reinforcements, or punching reinforcements here, but only the concrete durability, as we need this for the foundations. Additionally, new types for foundations have been edited. Here you can create foundations individually and edit them. Also under loads, when I go to load case, a new point for the additional foundation loads has been appeared. Here you will find everything such as earth covering, surface loads, line loads, concentrated loads, and groundwater. At the very bottom, another tab for concrete foundations has appeared. Here you can view and edit the design situations as well as the objects to be designed and the design configurations for the geotechnical proofs or concrete design. What I forgot to mention in the basic settings is that if you want to generate snow or wind loads using our load generator, it would be helpful to provide your location or these data under model parameters. If you don't want to enter them manually, you can simply select the location on the map and the latitude, longitude, and altitude will be automatically filled in, but they can also be modified here. I will show you now what has been modeled so far. Let's go into basic objects and materials. Here I have steel, concrete steel for reinforcement, as long with 3 different soils. When creating a new material, we can go to the library to load all kinds of soils. You can find them here under material type soil. I simply pick one of those now to show you the basic model parameters. However, you will likely receive different values from your soil report, so you can easily change the values in the material properties so that they are correctly considered in your verifications. Next, let's move to the cross sections. I've created 2 rectangular cross sections made of concrete and 3 different HEB beams. They can also be easily loaded from the library, just like the materials. Here you have different selection options. From this point on, it becomes interesting for the foundation modeling. Foundations must be assigned to supports. To do this, I will open the support type for nodes folder and access the nodal support. I've already created one here. I can either create a new one or edit the current one. So I have now set my support with my support conditions and would like to assign a foundation. To do this, I need to check the box foundation. When I do this, I get a new tab for foundations, and now I can select the foundation I want or create a new one. However, there is another way to create it. I will walk you through that method. The one here has already been prepared and defined. At the top, you can see all the nodes assigned to the support, and this foundation is then assigned to the support. Accordingly, these are also the nodes for which the foundation slab is defined. Now I will go to foundation types and create a new single foundation. Here you can determine the type of foundation, which can be a foundation slab with or without reinforcement, a block foundation with smooth bucket sides or with rough bucket sides. You can also, when you select one of them, see the graphic over here. Then we have bucket foundations with smooth bucket sides or with rough bucket sides. And new implemented are step foundations, again with and without reinforcement. So far, only the geometry of the step foundation can be determined, as this type of foundation is still under development. Let me go to the foundation slab now. In the second tab, you can create the geometry. You can define the slab geometry with the dimensions of the slab and the slab thickness, as well as the eccentricity of the column above it. If a node or support has already been selected, the support dimensions will already be filled in here. The program automatically retrieves them. You can also define a base plate at the foot of the support. This is very helpful because in the steel joints add-on, the geometries are also directly transferred, and anchors or reinforcements can be applied and designed there. Now I'll say something about the reinforcement later. Let's go back to the concrete cover. This can be controlled via this tab. Here you can also see the durability. You can set different minimum concrete covers for the top, bottom, or sides. These values are automatically determined by the concrete durability settings. Alternatively, you can set these manually and adjust them as needed. Next, let's move to the soil properties. Here you have the settings for the subsoil. The conditions can be created as drained or undrained. For the definition type, you currently only have the single layer option. The multi-layer option is still in development. This can then be controlled through boreholes, or if you have the geotechnical add-on, you can define them in the future via a soil massive. Here you can also set the soil parameters for friction angles, groundwater level, and earth covering. However, I first need to pre-enter something in the soil layers. The gravel was automatically selected because it's the first material of the soil type. So that would be region A below the foundation. Region B would be beside the foundation. I can define that here. I'll just add sand for now. If I want to have earth covering, I also need to fill in region C. Then there is the option of earth covering here, and I can enter the thickness. Let's say it's 1 meter. I can see that directly here. That's 1 meter above the foundation node. Now let's move on to the geometrical configurations. Here you'll find all the safety factors and other factors you need for design verifications. These can be controlled by reviewing or editing the geotechnical design configurations. The parameters you just saw can be set here in the standard parameters. In the basic settings, you can also deactivate design loads if you don't want them. You can also assign different design configurations to different foundations. Accordingly, you can decide individually for each foundation which settings should be activated or deactivated for the foundation design. For ground failure, there are two options for determining the ground failure resistant. It can either be calculated according to the error code, or you can manually enter a characteristic value. For the sliding verifications, there are also adjustment options. Here you can control whether the equilibrium, uplift, or the large eccentricities should even be considered for the verifications. Now let's move on to the concrete configurations. This section is similar. There are many safety factors here, as well as material parameters and ultimately everything we need for the design. You can adjust these here. In the basic settings, you can also determine whether punching shear should be considered in the design and how the handling of the minimum and maximum reinforcement should be managed. The position of the design section can be set here at the top. Now let's move on to the additional foundation loads. To do this, I will go to the Loads folder into load case 1, and here to the additional foundation loads, where I will create a new one. For the load types, we have surface loads, line loads, and concentrated loads available, as well as earth covering and groundwater. The surface load can be applied to the entire foundation by simply assigning the foundation and setting the load size. Line loads are similar, but here you can also define 2 points on the foundation between which the line load should act. These ordinates have the node of the foundation as their center. Let's move on to the concentrated loads. This works the same way. You can determine the location of the concentrated loads through the ordinates. Again, depending on the node of the foundation, and define the components in the X, Y, and Z direction. The earth covering is automatically generated by the system. You can control this through the soil properties when editing the foundation itself. The same goes for groundwater, which is also automatically created. I will go back to show you. In the self-weight load section, I have enabled earth covering, and it's why it appears purple here, since it has been automatically generated. If I go back into the foundation, into the soil properties, this is where I can define it. The weights from the earth covering are also considered here. So there's no need to calculate the earth covering or convert it into a surface load manually. Now, let's move on to the corresponding characteristic load combinations and the design regulations. To do this, I will go into the load cases and the basic settings. If the combination wizard is enabled, the box for automatically assigned corresponding load combinations should also be checked. Accordingly, you will later have the load combinations generated by the load wizard in the load combination section. Therefore, you will later find the combinations generated here, and the corresponding combinations should also appear. The ground failure and the sliding safety verifications can only be carried out with the assignment of these characteristic loads. Manual assignment is also possible. So if you don't want to use the load combinations from the combination wizard and prefer to create them manually, you can also add the corresponding characteristic loads via this drop-down menu here. Now, let's have a look at the design situations. For the geotechnical verifications, we need the ULS, ultimate limit state, for permanent and transient loads. We also need the design situation for equilibrium of structures for both permanent and transient loads. You can set all of them here. In addition, the one for accidental influence, and of course the characteristic one, which we definitely need to assign. What I forgot to mention earlier is that for the additional foundation loads, we need to activate the self-weight for the concrete foundations in the load case, where the earth covering should also be considered. This will add a new tab at the top. When we go to this tab, we can specify exactly what should be included in load case 1. In this case, I added the active self-weight of the foundation structure to the self-weight and included the earth covering. I placed the groundwater in a separate second load case because it can also positively affect the verifications. You can see that here. Now only the active groundwater is included into this load case. Now let's go to the reinforcement input, which I skipped earlier. For the foundation plate, you can define the material and the reinforcement type here. As mentioned earlier, you can choose from mesh reinforcement, reinforcement bars, or a combination of both. I've chosen a combination of both here. I will then go into the plate reinforcement. Here I can define what I want to lay for the upper and lower reinforcement individually. First, we have the definition of the mesh. Again, there's a section of various meshes I can choose from. The bars can also be defined in the X and Y directions, with diameters and spacing. The same applies to the lower reinforcement. Here I can define the mesh and the bars in the X and Y direction. What might be interesting here are the areas 1 and 2. Area 1 is the outer quarter, both left and right. Area 2 is the middle section. Now you can also view the reinforcement arrangement in our program. To do this, I will first turn off the upper reinforcement so we only see the lower reinforcement. Now you can see the number, the rolled diameters of the reinforcement, and the position numbers. The same can be done for the upper reinforcement, where you can also see the mesh designation. And through this button, you can print this graphic directly into the printout protocol. But I will talk more about that shortly. I also wanted to show you the reinforcement input for the bucket foundation. Here I will choose a bucket foundation. The geometry does not yet have a support because I have not assigned a node or a node support yet. I will do that quickly. Now we can go into the plate reinforcement. It looks the same as with the foundation plate. The bucket reinforcement has now been edited as well. Here you can define the horizontal stirrups first. You can also define the vertical stirrups in the walls in X and Y direction. Let's take another look at this. To display the bucket reinforcement, this button must be activated. I've turned off the other two for now. And here you can choose between different views to display the bucket reinforcement in all three views. Next, I'll give you a more detailed overview of the geotechnical design checks, which are an essential part of evaluating the foundation stability and safety. I already had the system perform the necessary calculations in advance to save time. I will go ahead and turn on the results here and navigate to the concrete foundations. In the overview, you can see that one of the design checks has not been fulfilled. I'll go into more details on that shortly. Here you can view an overview of the relevant results, which gives you insight into the performance of each foundation. This overview is sorted per knot number. Additionally, it shows which design checks have been carried out for each foundation. Let me make this a bit smaller so we can clearly see the names of the checks as well. First, we have the ground failure design check. When I go into that, we will see the complete calculation process for this specific check. All the necessary details are provided here, including cross-section values and design forces that contribute to the calculation. This helps ensure that the foundation will remain stable under the given loads. Let's take another look at the top here, where you can find these results. In the navigator under Results, you can easily view the geotechnical design under the Design Check section. Specifically, in the ultimate limit state, you will find the number UL 7300, which corresponds to the ground failure design check. If we click on that, you can view the utilization for each individual foundation. This will show you how close each foundation is to reach its limits. Additionally, you can also see individual stresses here, which provides an understanding of how forces are distributed across the foundation. If necessary, you can also view the failure figure. which helps identify the exact area of concern. Moving forward, I also have the sliding design check, which is another important aspect to consider the evaluation foundation stability. You can also view this design check for each individual foundation, ensuring that sliding movements are within acceptable limits. Furthermore, here is the design check for the equilibrium of structures, which has been exceeded for some of the foundations. Since this involves tipping around an edge, you can also display which edge is critical or which design check has not fulfilled. Looking at this, I see that for these three foundations, tipping around the right edge has not been fulfilled. Similarly, I can review another direction of evaluating tipping risks. Here is the other one that fails the design check, followed by the other three and the last one. Each of these design checks are important to ensure the foundation's structural integrity. Next, we also have the serviceability limit state. I now have the design check for large eccentric loading, which examines how the foundation responds to unevenly distributed forces. You can view this design check here as well. And here you can also see the existing eccentricity, which refers to the distance from the center of gravity of the load to the center of the foundation. You will also find the maximum permissive eccentricity in both the X and Y directions. This helps assess if the foundation can handle the eccentric loading without compromising its stability. If you can recall, I had also enabled punching shear earlier, which is another critical design check for foundations under concentrated loads. Accordingly, I can now go to the concrete design checks section in the ultimate limit state and examine those specific design checks. For punching shear, the number is UL 2400, and here you can see the punching cone, which indicates where potential shear failure may occur. You can also view the individual parameters related to this check to better understand the calculations. And here is the stress distribution again, showing how stresses are spread across the foundation surface. Since I have several foundations in a row, I can also choose to display just one foundation at a time to get a more focused view. This way, I can see the exact stress distribution for that individual foundation. I will hide this view now to keep things clear. Now, at this point, you can also display the reinforcement for the foundation intervention. This will show you the type and distribution of reinforcement in the foundation, which is crucial for ensuring the foundation can withstand the applied loads. You can view the upper reinforcement here, for example. This is the reinforcement in the X direction at the top of the foundation. Similarly, this is the reinforcement in the Y direction at the top. The lower reinforcement is displayed in the same way, providing a complete picture of how the foundation is reinforced. Let me switch the model to wireframe mode so that we can only view it from the top. This view allows us to see how the reinforcement is distributed more clearly. This way, you can also see in more detail where and how much reinforcement is involved, ensuring that every part of the foundation receives the necessary support. The same applies to the existing reinforcement, which you can also display. Then you can view the top reinforcement in both directions as well as the bottom reinforcement in both directions. And you can also see here the uncovered reinforcement, which should be 0 everywhere, indicating that no areas of the foundation are left without adequate reinforcement. Perfect. This is done analogously for other types of foundations, as well as for the bucket reinforcement, ensuring the structural integrity of the entire foundation. Now, let's take a look at the printout protocol. I will create a new printout protocol here. In the printout protocol manager, you can manually decide what exactly should be included in the printout. I will start by reducing everything, selecting all, and then deactivating everything. Now I will only select the items that are relevant for the foundations. So I've selected the folder types for foundations here. Let's see what we have. For example, I don't have rough bucket reinforcement, but I do have plate reinforcement. These are the relevant options for this model. In the loads section, we also have the additional foundation loads that I'd like to include just to show you. Of course, I can select many other options, but it depends on your specific needs. Next, I can select the reinforcements, both required and existing. I will probably do this on a by foundation basis, or the relevant results would be enough for me here. I'd also like to include a design summary. Let me generate this now. This is how the printout protocol looks. Here we have the table of contents, and then it directly starts with the types of foundations. Here you can see again the types of foundations we have, which node they are assigned to, the material assigned, and then the geometry you selected. If you had several foundations, you would see a list with multiple tablets like this. Then we have the type of reinforcement, whether it's a mesh reinforcement or rebars, and the materials for the reinforcement steel. Next, we see the concrete cover for the foundations and the amount of reinforcement laid out, both in the mesh in the X and Y direction at the top and the bottom. You can also see the selected soil properties here, or rather the soil layers that we've chosen. This includes earth covering, groundwater, and the friction angle. Finally, we have the global settings. For example, the design approach is set to approach 2, which is relevant for the ground failure design check. I didn't show you the global settings earlier, so let me go back to the model to the foundations input. And then you will find the global dialog for settings. Here you can select the design approach. As I mentioned, this is important for the ground failure design check. Now I'll go back to the printout protocol. Here I have also included the design situations for ULS, the equilibrium of structures, as well as the accidental and characteristic cases. I've also output the configurations for the geotechnical analysis. Then here are the arrows and warnings. The design check for equilibrium of structures was not fulfilled, as I showed you earlier. Next, we have the plate geometry and the utilization at the nodes. Node by node, this will be a bit more detailed now, as we have a few node foundations. But here you can also see in detail at which node, which foundation in which result combination did not pass the design check. Now we have all the design checks listed here. As mentioned, there are quite a few right now. Next, let's go back to the existing reinforcement. You will also see a list for the upper and lower reinforcement. Then the required reinforcement is shown, followed by the design summary. There are no images for the reinforcement or the model included yet, except on the cover page, where you can briefly see the model. Here you can also customize details like the project name, the client, and who created the model. Now I'm going to exit for a moment because I want to add 1 or 2 things to the protocol. To do this, I'll go into my foundation, go to the plate reinforcement, and then to the details. I want to include the lower reinforcement first. I can do that by going to the printout protocol at the bottom. It's already there. You can also give it a custom name here, just for lower reinforcement. Otherwise, I'll leave everything as it is. Then I'll also add the upper reinforcement to the printout protocol, so reinforcement on top. Okay. Now I can also include individual design checks in the printout protocol. For example, I include the equilibrium of structures for node 1. Now I want to have this design check in the printout protocol. Then I can click here into print to printout protocol. Now I'll switch back to the printout protocol to show the changes. So here at the bottom, I have the design check included under results directly below the results section. Here you can follow the entire calculation process, and all the variable names are included as well. You can take another look at both the lower and upper reinforcement here. Ultimately, everything you see in this display window can also be transferred to the printout protocol. To do that, I would first like to take the required lower reinforcement from the slab. I will hide the reinforcement bars, meshes, nodes, and supports for the view to make it a bit nicer here. I can do that by going to Types for Concrete Foundations Reinforcement by simply clicking this checkbox. I don't need to see the node, and I don't really need to see the support right now either. This is the way I would like it printed. Now I can go to the printout protocol at the top and get this view. I can directly print it into the printout protocol by pressing this button. I can do the same for any other design check as well. I will take the punching design check for now. Then I'll click print and select the area I want to show as the view is not suitable for me. I can do that by simply clicking 2 points here. And that's all from me for today. It was a real pleasure to give this seminar, and I sincerely hope you enjoyed it as much as I did. If you have any further questions, feel free to leave them in the comments, and I'll be happy to answer them. Now I'll say goodbye, thank you, and take care. I'll give the word back to Andreas.
Thank you, Ann-Kathrin, for your presentation. I have an additional hint to our online courses. You can book the courses for Rfem 6, that's a course for beginners, the Eurocode 2 course for the reinforced concrete design, the Eurocode 3 course for the steel design, the Eurocode 5 course for the timber design with Rfem 6. Then there are also packages available. For more information and prices, just scan the QR codes in the middle, or you can click on the button or buttons below here. Okay, and you can download the slides from our website, also the model, and you can watch the recording. In the next days, you will get an email with the link to that page, and the email contains also your attendee certificate. Let's show the website. That's the last hint for today. You can join the Dlubal community. You can see that above here on our website. You can communicate with us or our users or Dlubal users. It's for free. Just join the community. Okay, that's also all from my side for today. I thank you for your attention. Thank you, Ann-Kathrin, for the presentation. I wish all a nice rest of the day. Bye-bye.